Our company is working with individual AI, and where we actually try to get up on the level what we call about a digital twin. And what is the benefit here? For example, take for example individual learning. Let's take learning generally. For example, when you have big classes, for example in university, when you see with 5 to 1,000 students, we know the effect of the communication is less effective than you're sitting teaching one-to-one person. This is the most effective way to learn, individual learning. And we believe to develop a technology to a digital twin, we can take learning to individual. And let me actually illustrate here how I can take learning and go in what direction I want. So, hi here, when we talk about the first principle, can you tell me just shortly what it's about?
The first principle is about breaking down complex problems into basic elements. This method helps in understanding the fundamental nature of a problem, making it easier to solve. It's often used in science, engineering, and philosophy. Anything else you're curious about regarding this?
Okay, I work with AI. I'm not specialist in quantum computer, but what wonder me when we talk about first principle, quantum computer and AI, can you very shortly just give me a little relationship here?
Absolutely. When we talk about the first principle in relation to AI and quantum computers, we're looking at how basic quantum principles can fundamentally enhance AI. Quantum computers operate on quantum bits, enabling them to process complex large-scale problems much faster than classical computers. This speed can significantly advance AI's learning and problem-solving capabilities. It's a field that blends quantum mechanics' fundamental principles with AI's advanced computation. This combination could lead to groundbreaking developments in AI efficiency and capability. Does that help clarify the relationship for you?
Yes, but as far as I understand, I'm not sure about the year, I think it's 94 or something like that. When we talk about Peter's Fair, you talk about correction, error correction in quantum computer. When we talk about logic qubits, how does it work related to this?
You're likely referring to Peter Shor's work from around 1994, which is pivotal in the field of quantum computing. Shor developed an algorithm for factoring large numbers efficiently on a quantum computer, a breakthrough in the field. This ties into the concept of logical qubits and error correction. In quantum computers, qubits are the basic units of information, similar to bits in classical computing. However, qubits are prone to errors due to their delicate quantum state. To overcome this, quantum error correction is used, which involves encoding a single logical qubit into several physical qubits. This redundancy allows the system to detect and correct errors without collapsing the qubit's quantum state. So, the relationship between logical qubits...
As you can see here, I can keep pushing it in exactly what direction I want to do. So I can take it from first principle over to quantum computer, down to how you solve the logic qubit issue. And it is actually what we want with this individual learning. It is not prepared what direction I wanted. I can also ask it, for example, if I want quantum computer, give me the 3 most important basic things to understand, and it will give me 3. And it is actually what we make research about. How much information do we need to feed with for example, take any teacher or lecture. How much information do we need to feed into LLM model so it actually can become that person? Because if it can become that person, we can really talk about individual learning on the next level. And it is really what we want to achieve here. And it's why we work with the university about to make this individual learning, to make this digital twin, and on top of that, put all the security and privacy into it. But this is another topic. But it's actually just what I want to demonstrate here. Actually, one of the way of learning, it is to talk and interact back like you talk with a person. That is also, when we talk about digital twin, you have an avatar, you have the sound, you have a real person you're talking with. So you really get the feeling about interaction, because we know this is the best way to learn one-to-one person. But it exactly what I want to show you in this video. Hi.